Assalamualaikum and hi, my name is Amar Faid bin Izanul Weka and I will be presenting about data mining and diabetes. So data mining is the process of discovering patterns, correlation and anomalies within large data set to predict outcomes. By leveraging statistical model, machine learning and database system, data mining transforms raw data into valuable information. Key techniques include classification, clustering, regressions, association rule learning, and anomaly detection. Data mining is widely used in various industries for tasks like customer relationship management, fraud detection, market basket analysis, and healthcare analytics. The dataset consists of 3,000 instances and 22 attributes that include clinical symptoms, laboratory test results, and patient demographic. There are 12 numeric attributes and 5 nominal attributes in this dataset. And this dataset doesn't have missing data.
Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Hazika and I'm going to talk about the introduction of clustering. The centroid-based clustering approach is known as K-means. Centroid-based algorithms are sensitive to outliers and initial factors. Clustering divides the datasets into K clusters by iteratively matching each data point to the closest centroid and updating the centroid to minimize the sum of squared distance inside each cluster. Key centroids must be initialized at random and each data point must be assigned to the closest centroid using Euclidean distance in order to do K-mean clustering. Next, calculate the mean of all the points assigned to each centroid in order to update the centroid. Continue step 2 and 3 until convergence is achieved, which is maximum number of iterations is reached or centroid changes do not occur. Visualizing cluster uses scatter plot or other appropriate visualization to demonstrate how data points are grouped based on similarities will be the approach for the model visualization. Use measures like the silhouette score or inertia in order to assess the quality of clustering in the model review process. In order to determine how similar each point is to its own cluster in relation to other clusters, the first step will be to compute the silhouette score. Next, calculate the inertia to determine the degree of compactness of the cluster. In this case, lower inertia implies better clustering. For interpretation, examine sample data point in each cluster or analyze central attributes to interpret the cluster. First, list the characteristics of the centroid that set one cluster apart from another. Next, examine cluster attributes to identify trends or new information in the data. Hierarchical clustering algorithm in data mining produce a tree of clusters. Hierarchical clustering, not surprisingly, is ideally suited to the hierarchical details like taxonomies. By combining or dividing clusters according to similarity matrix, hierarchical clustering creates a hierarchy of clusters. Initially, every data point is a single-term cluster. Then, iteratively combine the nearest cluster until every point is a part of a single cluster. As an alternative, create a single cluster that contains every point, then divide it recursively until every point has its own cluster. Use dendrograms to visualize cluster and demonstrate hierarchical linkage as well as cluster merger and splitting. Analyze hierarchical clustering by visual inspection of dendrogram or measures such as the covenantic correlation coefficient. Examine dendrogram structure to interpret cluster, noting cluster at various hierarchical levels. To get insight from the hierarchical structure, divide the dendrogram into clusters by cutting it at a suitable height or distance threshold. Then, we can examine the composition and traits of each cluster.
K-means clustering is a method for partitioning a dataset into k-distant and non-overlapping clusters. The goal is to minimize the variance within each cluster while maximizing the variance between clusters. Euclidean distance is the straight line distance between 2 points in multidimensional space. It is effective for low to moderate dimensional data and common in general clustering tasks, image compression, and pattern recognition. Manhattan distance, also known as L1 distance or city block distance, measure the path between 2 points along axis at right angles. It is effective in image processing and supply change optimization, where grid-like structure or awkwardness to outlier are important. Clustering is a method of clustering that builds a hierarchy of clusters either through an agglomerative approach or divisive approach. Simple hierarchical clustering typically refers to agglomerative clustering, where each point starts in its own cluster and pair of clusters are merged as one move up the hierarchy. Complex hierarchical clustering typically refers to clustering methods that go beyond basic agglomerative or divisive approaches. This method often incorporates more sophisticated techniques to handle large, high-dimensional or intricate datasets. It also may involve advanced linkage criteria, hybrid approaches combining hierarchical and partitioning methods, or the integration of additional data type and constraints.
Hierarchical clustering can be used to investigate the hierarchical links within a dataset. After putting the dataset into Weka Explorer interface, cluster tabs were chosen and hierarchical clusterer were selected from the list of clustering techniques available. Euclidean distance metrics were chosen and complete linkage type were used in this dendrogram. The dendrogram provides a visual representation of how the data points are grouped based on their health attributes. By cutting the dendrogram at different heights, we can determine the number of clusters to analyze. A lower cut will result in more clusters, while a higher cut results in fewer broader clusters. At the bottom of the dendrogram, we see many small clusters forming at low heights. These clusters represent individuals with a very similar health profile. For instance, individuals who are physically active, have good general health, and do not have high blood pressure or high cholesterol might cluster together early, showing high similarity. As we move up, these small clusters merge to form larger clusters. At the very top of the dendrogram, the largest cluster form, often encompassing all individuals with overarching similarities, such as those diagnosed with diabetes. These clusters represent the broadest grouping, showing how individuals with varying degrees of similarity can be grouped into larger categories based on their health attributes. A clustering confusion metric is a table that displays the relationship between the clusters assigned by the clustering algorithm and the actual clusters of the data point. Unlike a confusion matrix in classification, which compares predicted labels to true labels, a clustering confusion matrix compares clusters to true labels, since clustering does not use the true label during the learning process. With the dataset loaded, switch to the cluster tab to perform clustering. Select a clustering algorithm such as simple k-means by clicking on the Choose button. Configure the clustering algorithm as needed, specifying parameters like the numbers of clusters. Start the clustering process by clicking Start. The resulting confusion matrix will show how well the clusters match the true labels in your dataset. Rows represent the true clusters, which columns represent the clusters assigned by the algorithm. A clustering confusion metric is a table that displays the relationship between the clusters assigned by the clustering algorithm and the actual clusters of the data point. Unlike a confusion matrix in classification, which compares predicted labels to true labels, a clustering confusion matrix compares clusters to true labels, since clustering does not use the true label during the learning process.
Now, in clustering, we would want the best model to use for the clustering, which is where clustering analysis comes into play. And here, once we've done all of the clustering method, which is k-means, single, and complete hierarchical in both Euclidean and Manhattan distance on k equals to 2, 4, and 6. Once we've done all that, we will take the values of the incorrectly clustered indices in the percentage and make a graph to compare between those two. Now, in Euclidean distance, the majority of the results here is lower compared to Manhattan. except for complete hierarchical clustering on case 6, which has lower than Euclidean distance. But since most of them is lower in Euclidean distance compared to Manhattan, therefore we will take Euclidean distance rather than Manhattan. And in Euclidean distance, the lowest instances is 37.84558 on k-means, 28.6067 on complete, and 0.0494 on single clustering. And that is on K2. Since the K2 shows the lowest value of incorrectly clustered instances, therefore K2 is the best. And the lowest value is 0.0494. However, the inaccuracy is absurdly low, which means that there must be some kind of errors in the data. Therefore, we will take complete hierarchical clustering because this inaccuracy is way too low. Therefore, there must be some inaccuracy in the data, so we cannot take that value. So we'll be taking the complete hierarchical on k equals 2. However, on k equals to 4, the value of the incorrectly clustered instances remains the same. Therefore, it's actually better to take a complete hierarchical clustering on k equals to 4 because more clusters meaning more accurate. Since the incorrectly clustered instances remain the same despite having more clusters, therefore k equals to 4 complete hierarchical clustering is the best suited for this clustering method. So the interpretation, which is basically what we can interpret on the data, and first we will want to open the data and we will want to change the on a specific one from numeric to nominal. This is on diabetes on our 17, so change this into 17. Okay, and click apply, and make sure that it is nominal. And we have to go to cluster, classes to clusters evaluation, and click on diabetes. And we would want to pick simple k-means and then click start. The setting is on default and the number of clusters is 2. And here we will get 2 clusters, full data being 2024. The first cluster having 816, while the second cluster has 1208. And this is the normal value. So anything below this is basically a no, and anything above this is a yes. So for example, in cluster 1 we have 0.6765, which is above the full data, which means that they do have high blood pressure. Meanwhile, in cluster 2 it has 0.356, which is below the full data, which means that it does not have high BP. And another example is on the full data we have 28.6952. In cluster 1 we have 28.3725, which is lower, which means that their BMI is lower. They have low BMI compared to cluster 1, which has 28.9131, which is higher than the full data, which means that they are overweight, which is above the normal BMI. And from this attribute list we can also get another information such as whether they eat vegetables or not, or whether they have heavy alcohol consumption. We can also get to see their mental health, in which that those with diabetes usually have lower mental health than the full data, which means that they have a bad mental health, and that kind of makes sense as those that doesn't have diabetes has a good mental health. However, the surprising one is that those with lower BMI than, which is lower than the usual amount, which is underweight, etc., is the one to get diabetes a lot rather than those with higher BMI. And based on all of this data, we can basically interpret that those that has diabetes usually have high BP and high cholesterol, and they have done their cholesterol check, has lower BMI, does not have stroke or heart disease or attack, and they don't do physical activities. They do eat fruits and vegetables, however, but that does not help with their diabetes, as it helps generally in their health. They does not consume heavy alcohol, and general health is above the full data, which means that they have a good general health but bad mental health, but good physical health and have difficulty walking. Meanwhile, in cluster 2, we see that those that does not have diabetes have high BP. They do not have high BP, my bad. They have lower amount than full data, which means that they does not have high cholesterol. They've done their cholesterol check. Their BMI being above average, whether it be overweight or obese. They do not have stroke, heart disease or heart attack. They do physical activities. They does not eat fruits, and they does not eat vegetables. And however, they do consume alcohol. The general health is lower than the full data, which means that they have a bad general health but a good mental health and a bad physical health. They do not have difficulty walking as well. So from this, we can assume that we can interpret that alcohol does not contribute to diabetes, and fruit and vegetables does not prevent diabetes as well, as it just provides for a good general health rather than preventing diabetes.
Last but not least, in terms of data must be processed in order to handle missing values, normalize features, and reduce dimensionality before clustering. Making decision is informed and knowledge is improved by this approach. Information plays a crucial role in the data hierarchy, transforming raw data into structured format that provides context and meaning. Clustering algorithm groups single data points based on specific criteria, simplifying large datasets and revealing initial patterns. In terms of knowledge, clustering algorithms help transform organized information into actionable knowledge by identifying significant groups and revealing meaningful patterns. They also help in pattern recognition, revealing risk factors, common comorbidities, and demographic trends. The knowledge is validated using internal metrics and external benchmarks to ensure reliability and meaningfulness.
Next is knowledge, derived from analyzing and interpreting information, with clustering algorithm play a role in deeper analysis, pattern recognition and validation, such as identify high-risk age group. For this is a wisdom, which is referred to the application of knowledge for informed decision-making and planning, with clustering algorithm providing strategies insight, data-driven decision-making, and continuous improvement in healthcare strategies.